All right, so example 5, we're going to use composition. Same composition that we talked about last section. And we're going to put it to new use. We're going to let it verify that two functions are inverses of each other. Okay, so first things first, let's actually find the inverse of 2x plus 5. So in the example just above this, right, just last example, you guys were like, all right, bring back y, make it y equals again, and then we know that, well, we switch x and y when we talk about inverses, and then as we typically do, we're always looking to solve for y equals, so we go and do this, and we get 1/2 x minus 5/2 equals y, which this is our inverse. Okay, so our original is 2x plus 5, and our inverse is 1/2 x minus 5/2. And what we're going to do here is we're just going to show ourselves that through composition, we can actually verify that these two things are inverses. And watch, this is how we do it, is that we need both f of g of x and g of f of x must equal x. And guys, when we say f and g, it's just like function 1 and function 2. I understand that here we're using f inverse of x. So we could easily just call this g. Like once you find the inverse, we could easily just call this g of x. It really just means function 1 and function 2. Function f, function g. Whatever the case is, whether it's f, f inverse, g, q, p, doesn't matter. Okay. So both, this is a huge point here. This is where the composition comes in. Both f and g f of g and g of f must equal x. And watch, you're going to see how this goes. All right, here we go. So let's just agree. Let's call the inverse. Let's just call this g now. Okay, so we're going to call the inverse g. All right, here we go. We're going to do f of g of x over on the left, and we're going to do g of f of x over on the right. And we're going to show that when they both equal x, that's how we can prove that they're inverses. All right, so we're going to do f of g. So this is the f function, and we're going to put in 1/2 x minus 5/2. So we're going to do 2. We're going to replace we're going to replace x with 1/2 x minus 5/2, and then a plus 5 on the end. So we're going to distribute. 2 times 1/2 is 1, so that's just x. The 2's cancel, so we're going to get minus 5 plus 5. And hey, look at that. The 5 and the plus 5 cancel. Boom. We get x. Now, if we do g of f of x, so we're going to do the g function of 2x plus 5, which means that we're going to do 1/2, replace our x, everywhere you see an x, right? Replace it, minus 5/2. Distribute the 1/2. 1/2 times 2 is 1x. 1/2 times 5 is 5/2, minus 5/2. See where this is going? Plus 5/2 minus 5/2. Boom. X and x. So they are inverses because by this sheer fact that both of one function in the second and the second one into the first both equal x. Okay, now if we go down to example B here, we're going to see a case where, spoiler alert, they're not inverses. So we no longer have to go through a process of actually finding the inverse. Sometimes we're just going to be asked if these two functions are inverses of each other. And so we are going to use composition. All right, so let's first try f of g of x. Okay, So we're going to put the g function of the square root of x minus 5 in for everywhere we see x. So we're going to put it in square root x minus 5 squared plus 5. This is really a binomial squared, so that means we need two of them. So FOIL in here, x square root x times square root x is x, square root x times negative 5 root x, negative 5 root x, negative 5 times negative 5 is 25, plus 5, we get x minus 10 root x plus 30. Ugliness, gross. So we have all this other stuff that's not just x, right? We have all this other stuff over here. So this automatically fails. So these are not inverses because one of the compositions did not equal x. So we don't even need to test. There is no need to test the other direction, g of f, because they have to both be true. So if one fails, it all fails. So if you are looking to verify whether or not two functions are inverses of each other, you need to do composition. Start with one, do one inside the other. If you get x, go to the other one. If you don't get x, you can stop because once one fails, it all fails. Okay, so try those two try problems. You got your A and your B there. Make sure that you're doing distribution when you need to. Make sure you're applying your rules of exponents properly and all that stuff. But remember, both f of g and g of f must equal x if we can call the two functions inverses.